Good day, viewers all over the world. Today, we want to look at Bernoulli's equation. So, this is one of the solution to the system of differential equations. So, what do we know, or what do we understand by Bernoulli equation? If you check one of my past videos, we have actually talked about this Bernoulli equation. So, a Bernoulli differential equation has this form. This form is almost the same thing as linear differential equation. The only problem is that under the linear differential equation, y n here is either raised to power 0 or 1. So in the linear differential equation, we don't have function of y at the right hand side. Okay, where n is a real number. So how do we now solve this Bernoulli equation? We can solve this Bernoulli equation by reducing this Bernoulli equation to a linear equation with other variable like variable z. That is, we say the substitution, if we substitute z to be equal to y raised to power 1 minus n, the substitution of z equal to y raised to power 1 minus n transform Bernoulli equation, differential equation into linear differential equation of the unknown function z. That is, what we are trying to say is that how do we remove y raised to power n at the right hand side so that we can reduce this Bernoulli equation to a corresponding linear equation, which puts or substitute z equal to y raised to power n. So whenever we see z here, then if we differentiate z with respect to s, the z dy is going to give us this. Okay. So if from this Bernoulli equation, if we divide through by y raised to power n, we are going to get this. Then since we have this, we have 1 minus n here. If we multiply through by 1 minus n, we multiply through by 1 minus n. This is what we are going to have. We are going to have n. We are going to have, if we multiply through by 1 minus n, we are going to have n minus 1 y minus n dy dx plus n minus 1 p of x y raised to power 1 minus n is equal to 1 minus n q of x. And at the end of the day, we substitute back. You realize that everything that we have here is same thing as dz, is same thing as dz dx. Okay? It's same thing as dz dx. It's same thing as dz dx. That's same thing as dz dx plus n minus 1 p of x y. This is same thing as z is equal to 1 minus n q of x. So we have been able to reduce this Bernoulli equation to a linear equation here. But that linear equation is a function. That linear equation is a function of z. So that is the only way to solve a Bernoulli equation. When we are given a Bernoulli equation, we have to reduce that Bernoulli equation to a linear equation with another parameter, maybe parameter z in this case. Then we'll be able to solve it. So let's take example. I want us to take example under Bernoulli equation. Once we know the general form of Bernoulli equation, then we have little or no problem with the solution. So let's take example under Bernoulli equation. Let's take example one. The first example under Bernoulli equation, example: solve dy dx plus 1 over xy is equal to xy squared. So that's what we are given. That's the Bernoulli equation. How do we solve this? How do we solve this problem? For us to be able to solve this problem, let us first divide through. Let us first divide through by y raised to power 2. That is, if we divide through by that, we are going to have y raised to power minus 2 dy dx plus 1 over y raised to power minus 1, then is equal to x. That's the first step. Meaning that we have been able to substitute z to be equal to z here, will be equal to y raised to power minus 1. Then what will be the z dy? The z dy will be minus y minus 2 dy dx. That's what we are going to get. So please, let's check it very well. For us to be able to solve a Bernoulli equation, we must first reduce that Bernoulli equation to a corresponding linear equation with another parameter. In this case, parameter say z, and with another variable z. So with what we have on the board, so what is the next process? You know, we have minus here. So I can decide to multiply through by minus. I will multiply everything through by minus. So I'm going to have minus y raised to power minus 2 dy dx, then minus 1 over y y raised to the power minus 1 will be equal to minus x. So what is the next step? The next step is that we now substitute. You realize that dz dx here is equal to everything that we have here is what we have transformed here. So I will change everything here now to dz dx. Then what is z? Z is same thing as y raised to the power minus 1. I will change here to minus 1 all over y z is equal to minus x. So at this point now, we have been able to transform this Bernoulli equation to a linear equation. So since we have been able to do that, then we find the value of x, and when we find the value of, we are going to find the value of, no, this is x. This is x, 1 over x. Here is 1 over x. This is 1 over x. So from this point now, the next thing that we are going to do is that we are going to locate x, p of x and q of x. Here we realize that our p of x is equal to 1 minus 1 over x, and q of x is equal to minus x. So we go ahead and find the integrating factor. What is the integrating factor? Exponential integral p of x dx. That's how to find the integrating factor. When we have a linear equation, that's how to find the integrating factor. Then if that is the integrating factor, what do we do here? We just say this same thing as exponential integral minus 1 over x dx. Of course, this same thing as exponential, we can bring out minus integral 1 over x dx. Then this same thing as exponential minus, when we find what is the integral of 1 over x, that will be in x. That will be in x. Integral of 1 over x is the same thing as in x. So that will be in x minus in x. Of course, this minus can come up to have exponential in x raised to the power minus 1. Then the integrating factor finally will not be equal to exponential can take care of this in, so that we have it to be x raised to the power minus 1, which same thing as 1 over x. So in this case, our integrating factor is 1 over x. The integrating factor is 1 over x. So what will be the solution? What will be the solution of that differential equation? The solution to that differential equation in this case is z, not y. We say z multiplied by integrating factor is equal to integral q of x. Is the same thing as integral q of x multiplied by integrating factor the x. This is what you are going to do. So on that linear equation, if you want to find the solution, that's the solution. But in this case, it's a function of z, not y. But we are going to recall by the time we finish it. So the solution will now be, what is z? The solution will now be z multiplied by the integrated factor is 1 over x is equal to integral q of x is minus x multiplied by 1 over x dx. That's what we are going to get. That's what we are going to get. X can take care of x, so that we have z all over x is equal to minus integral dx. So this same thing as z all over x is equal to minus x plus arbitrary constant. That's what we are going to get. That's what we are going to get. Then if we multiply through by x, we are going to have z to be equal to minus x squared plus cx. That's what we are going to get. But we are given the question in form of x. The question is given in form of x, not in form of y, not z. So we say z is equal to, say, cx minus x squared. We recall that z is equal to y raised to the power minus 1, which same thing as 1 over y. So if we substitute back, because the question is given in form of dy dx, not z, we have to recall. So we now say z is equal to y minus 1 is equal to cx minus x squared. So from there, what do we have? We have 1 over y is equal to cx minus x squared. Then finally, if we cross multiply, we can have y to be equal to cx minus x squared, everything raised to the power minus 1. That will be the solution to this Bernoulli equation. That will be the solution to the Bernoulli equation. And that is what we have. That's what we have got in there. It's very simple and straightforward. So it's very simple and straightforward. So if you are given any problem, another Bernoulli equation, the first thing is that you should be able to recognize that problem as Bernoulli equation. Once we are able to recognize the problem, then we reduce the problem to the corresponding linear equation. with unknown function z. So if you are able to do that, then we have little or no problem. Let's consider another example. Y is equal to y raised to power 4 ex e raised to power x. I want us to consider another example before we close the lecture. So let's consider another example. Look at this. If you look at the equation on the board, you realize that these are binomial equation. It's a binomial equation because it has the function of y here, where n is raised to power 4. So the first thing that you do is that you multiply through. You eradicate it, so you divide through by y raised to power 4. So if you do that, you are going to have this to be y raised to power minus 4 dy dx plus y raised to power minus 3, because that's it there, it's equal to e raised to power x. This is the first step that we do. So from there now, if you're able to do that now, then you can say let z equal to y raised to power minus 3, so that the z dx will be equal to minus 3 can come down, minus 3 y raised to power minus 4 dy dx. That's the next thing. So look at what we have here and what we have here. The only difference is minus 3. So we multiply through by minus 3. We say multiply through by minus 3. That will be minus 3 y raised to power minus 4 dy dx minus 3 y raised to power minus 3 is equal to minus 3 e raised to power x. That's what we have. That is what we are going to get. So, of course, everything that we have here is same thing as dz. So I will represent everything as dz dx minus 3. What is y? What is z here? Y raised to power minus 3. That will be minus 3z is equal to minus 3 e raised to power x. So we have been able to transform this binomial equation to a linear equation here. Linear equation, but with the variable z, we have been able to transform that. So when we are doing binomial equation, the first thing is that we should find a way of reducing that binomial equation to a linear equation. So if you are able to do that successfully, then we have little or no problem. Then we identify p of x. P of x is minus 3. Y q of x is equal to minus 3 exponential x. That is what we are going to get here. So once you know p of x, you can go ahead and find the integrating factor. Integrating factor is exponential integral p of x dx. Then in this case is exponential, the p of x is integral minus 3 dx. At the end of the day, we have this to be exponential minus 3x. That's what we are going to get as the integrating factor. The integrating factor is exponential minus 3x. So what will be the solution? The solution will now be, in this case it's z, because we have z, not y. Multiplied by integrating factor is equal to integral q of x multiplied by integrating factor dx. That will be the solution. So here we have z multiplied by integrating factor is e raised to power minus 3x is equal to integral q of x. Q of x is minus 3 exponential minus x multiplied by integrating factor is exponential minus 3x dx. That's what we are going to get there. So that's what we are going to get there. So what do we do? From there, we combine what we have at the right hand side. So if we do that, this is raised to power x. If we do that, we have z exponential minus 3x to be equal to integral minus 3 e raised to power x. Here is x minus 3, that will be minus 2x dx. Then from there, we know what to do. From there, we can actually write out what we are given. So this will be equal to, we can bring out minus 3. When we integrate minus exponential minus 2x dx, that will be minus 2. When we integrate that, that will be minus 2 dx. So here we are going to have, I'm talking about the right hand side now. Here will be exponential minus 2x all over minus 2 plus arbitrary constant. That's what we are going to get. Z exponential minus 3x. That's what we are going to get. This will take care of this. We have z exponential minus 3x to be equal to 3 all over 2 exponential minus 3 all over minus 2x plus arbitrary constant. So what is z? What is z? We recall that z is equal to y raised to power minus 3. That is z. Then which is same thing as 1 all over y cube. So I'm going to have 1 all over y cube here, exponential minus 3x will be equal to 3 all over 2 exponential minus 2x plus arbitrary constants. Then finally, I just want to conclude. Of course, we can leave the answer at this point. If you don't want to stress yourself, you can just leave the answer at that point, or just divide through by exponential minus 3x, so that we have 1 all over y cube to be equal to 3 all over 2 exponential. If you divide that, that will be x, okay, plus c exponential 3x. That's what we are going to get. That's what we are going to get. We can stop at this point. We might decide to stop at this point, or if you want to continue further, just find the LCM here. We rewrite everything. Then at the end of the day, we'll find the cube root. But we can just stop at this point. At least if you're able to do it to this point, go on the safer side. So I would love to stop here. Thank you.
This thing's a stop.